For our math warm-up today, we are going to take a look at 5 different numbers here. And we are going to write an equivalent expression using multiplication or division and a power of 10. So I want you to think about that for a minute. Pause your video and see what you come up with. You may have come up with something different, but if you take a look, number 1, I have 3 6/10 times 10 to the 4th power. For our second one, I have 2 53/100 times 10 to the 5th power. For the third one, I took that one and made 50 divided by 10 to the 2nd power. For our fourth problem, 74,000 divided by 10 to the 4th power. And last but not least, the last one here is 104 divided by 10 to the 2nd power. Our math message today requires your student math journal. So go ahead and get that out. Open up to page 288. Pause your video if you need to. So let's take a look here. Clark has a juice box that is not completely filled with juice. The hole at the top of the box is open. Clark grabs the juice box and squeezes it, but the juice does not come out of the box. So we've got 2 questions related to that information. So let's take a look at number 1. What do you think happened to the shape of the juice box when Clark squeezed it is the first question. And number 2, what happened to the amount of juice in the box and the height of the juice when Clark squeezed it? So go ahead and pause your video, take some time to really think about those 2 questions, write a really good explanation, and if you need to, do some calculations, and come on back when you're ready. So let's take a look at number 1. At first, the juice box was a rectangular prism. When Clark squeezed the box, the sides of the box bent in, which some of you probably can relate to. The box was no longer a rectangular prism. All right, and if we take a look at question 2, the amount of juice in the box stayed the same because none of the juice spilled out of the box. This means that the volume of the juice stayed the same. When Clark squeezed the box and pushed in the sides, the height of the juice increased. Now, these are just sample answers. You could have explained it in a different way and worded it differently, which is completely fine. Our lesson today is a treasure hunt, which is open response day 1. We're doing this lesson to make sense of problems and persevere in solving them. We need to be able to reason through the problem by using words, pictures, tables, graphs, etc. And how we're going to go about that today is use what we know about volume to solve a real-world problem. So let's go ahead and take a look at what you will be working on today. So notice we've got 2 pages. The title of our open response is called A Treasure Hunt, And let's take a look here. It says a 5th grade class read an adventure story. In the story, an explorer named Miriam traveled to South America in search of a lost treasure. Traps had been set to guard the treasure. Miriam fell through a trap door into a 9-foot-high rectangular room that measured 4 feet wide by 6 feet long. Suddenly, the room began to fill with water. It stopped when the water was 3 feet deep. Miriam sighed with relief, but her relief didn't last long. The 2 4-foot wide walls of the room began to move. making the room smaller and causing the water level to rise. Every 10 minutes, the walls were 1 foot closer together. So we can take a look here. We have some diagrams that show us where the trapdoor is, the measurements, the water level as it begins to rise. So you want to think about what you know about volume. And again, this is the room after 10 minutes. This one was as it was filling. So we're going to take a look at question number 1. To the right is a picture of what the room looked like after 10 minutes, when the 4-foot wide walls had moved 1 foot closer together. What is the approximate height of the water? Show how you found your answer. So again, you're going to be doing approximate height. Think about what you know about volume. Think about where it is in 10 minutes. Is it going to be the same amount in 10 more minutes? Something to think about there. And how you're going to calculate all of that and explain it. And then number 2 over here on your second page, the only way to get out of the room is through the trap door in the ceiling. About how much time will pass before the water lifts Miriam to the trap door? Show your work. Explain how you used representations to help you solve the problem. So think about, what does representations mean? Does that mean equations? Hint, hint. All right, let's summarize what you're going to be doing today. Take what you know about calculating volume and use it to solve a new real-life problem. Be sure to use expressions, pictures, words, or whatever you deem necessary to do a good job explaining and solving the problem. You've got this. Good luck.